Hello, I'm your TA for Engineering 107. I'll be teaching you CAD today. My name is Kareem Elsharkawy. You can call me Kareem, or else I'll sound old. Don't call me by my last name. So we're going to start off here. First, about me. My office hours are on Monday from 10:30 to 11:50 a.m. and Wednesday from 4:30 to 6:30 p.m. These will take place at Horizon Hall, next to the Mix, at the bottom floor. You can contact me either by my email here or by my phone number. You can use whichever one's easier for you. Just preferably text and do not call me. So for a summary of what we're doing today, we'll be setting up OnShape for you. We will go over the sketch you did in class. We'll be creating a part in OnShape, and we'll go over a couple other basic CAD tools that we didn't cover while making this part. So first of all, what is CAD? CAD is short for computer-aided design. It is used to make 3D models, movement simulations, and the way they interact, parts interact between each other, stress simulations. You can make 2D technical drawings for your employers or manufacturers, and CAD also has very strong ties with 3D printing. So the types of models you can make and the three types of files that are available in CAD are the parts, assemblies, and the drawings. That will be clear later on, but today all we'll be going over is the parts. So first of all, when you're making CAD models, the first thing you'll run into is the fact that how do I make the dimensions on a part? You'll notice in this 3D plane it is very difficult to show dimensions of things. So a lot of times you have to start with the 2D part. All parts do start with a sketch. Almost every single model in CAD will start with a sketch. For instance, this is what a 2D model should look like. This is an example of a technical drawing, which we will show you how to do later. But in order to do this, you first need the model itself. CAD is honestly the best thing about CAD is the fact that you can make accurate dimensions for these parts. And enough going over slides, and let's do some OnShape. So first thing to set up OnShape, it's a browser-based program. So you just go to onshape.com. It should be the first thing that pops up in Google. And then you'll go to pricing over here. Okay. And then you'll go scroll down to students and educators, and you'll see this button here. Press EDU program. Next, we'll go to for students, and you will enter your first name, last name, email, you'll check with your student, go to university, check the box, create EDU account. Also pretty straightforward. Put your school name, which will be George Mason University, school website. That you'll find by just searching up the GMU website. It's very simple. It'll be www.gmu.edu. You can see it here. Which then you can paste into the box. But make sure there's no backslash after the address, or else it won't work. You'll see the check mark when it says it when you're inputted incorrect information. This is in Fairfax, Virginia. This is where the campus is located. And we're country. Pretty sure most of us are in the US, if not all. Graduated in 2023. Area of study. I'm studying computer engineering. Closest thing is electrical engineering, I guess. What are you using OnShape? You can say school. They don't check it. No worries about what you put in here. Check the boxes, saying you're only going to use it for school. Create your account, prove you're not a robot. It might be difficult for some, but it should be fine. Hopefully you don't get stuck there. Then they'll send you an activation email. Should be pretty simple. Go to here, activate your account. I already have an account, so I won't go through this process. But you'll submit your password. You'll end up here on this page. Next thing you need to do is go to create right here, and then you create a document. You can name it whatever you'd like. I'm going to name it part 1. Okay, so right here you are in the 3D plane. You will see several things in front of you. The most important things to notice is this is your origin. This is the center of the plane, and then you have your front, right, top planes. This will become more apparent and more relevant in the future. So right now, in order to to scroll around the your build space, you hold the middle mouse button and you can rotate around. In order to pan back and forth, you hold control and then middle mouse button. And then to scroll in and out, it's just the scroll wheel. It's pretty simple. This is always easier with a mouse if that's an option for you. If not, you can do just fine with the pad. So first thing you're going to want to do is, because we are sketching a flat object, it'll be easier for you if you start on the top plane. So what I'm going to do is, see your front and right planes. All your objects and features will be here in your features tree. So I'm going to click on this little eye right here on the front and on the right planes. So now there's less clutter on your screen. Next thing you're going to want to notice is this cube. This cube is very useful for panning around your build area. You'll become familiar with it very easily. You just click on the side you want to go to, and it will go to it. You click the little arrows, it will adjust from there. Very simple. So right now, the next thing we're going to do is we want to create a sketch. All you have to do is press the sketch button, and then now it'll prompt you for the sketch plane that you want to draw on. That means on what surface are you trying to draw. So here we're going to draw on the top plane, so you could either click it here or you could click it in the feature tree. I usually find it's easier to click it here, but sometimes it's a little funky. So now one of the things about our part is that it's easily defined by a rectangle. If you look at it, it is very clear that the part was cut out from a rectangle, so it'll be much easier for you if you first start with a rectangle. Let me explain. So first thing here, we're going to select our rectangle tool, and then we're going to make it a construction line. You do that by pressing this button here. You could also use the keyboard shortcut Q. So now you're going to have a construction rectangle, as you see here. Real simple. So now, but here's the thing. You want it to be dimensionally accurate. That's where your next tool comes into play. You are going to select the dimension tool, which is right here. You can also get to it by pressing D on your keyboard. So the top side is 8 inches. Also, this might be slightly different per class. As far as I know, every single class has slightly different measurements, but that shouldn't change the overall process. Should be fairly similar. So 6.5. Oh yeah, I have mine based in centimeters, so what I'm going to do is, my default units are centimeters, so I'm going to put inches after everything, and that should switch it to inches. It will automatically convert for you. That's a tip. If you have measurements in any kind of format that isn't inches and you want to switch to inches, you can always input it into whatever format and it will convert it for you. No biggie. So your next step is going to be to select your line tool. Now, one thing about construction lines is your CAD program will ignore them in the 3D plane, which that is important because we don't want it to define certain parts. It'll become apparent later. But here, when we're defining the perimeters of our part, we want it to be in normal, not construction. You'll know if it's construction if you see the construction icon is highlighted. So now we're going to trace over our part. I put one line, 2, 3, and then now you see if I want to leave the line tool, I just press escape. Very simple. Now I'm going to continue from up here, go over, one moment, go over, go down, go right, down one more time, and to the left. So now we have the general perimeter of our thing, but we're missing one point, one crucial feature. The arc at the bottom of the part, which we can then pretty easily, now we select the arc button, and then we go to center point arc. This is useful as we are defining this arc by the center, and we are doing measurements from the center. So here we're going to click on our line because we want the center of our arc to be located on the line. So now here it's asking us to select the radius. We are going to click on the edge of this line because we want the edge of our circle to be on the edge of our line. So we click there, and now we're going to select the arc length. And then now you want it to be coincident, which means touching our line. But now we have a weird overhang here. Do you guys see that? So now I want you to select both points here. So now both are selected, and you'll see up here in the top there is a bunch of relations. So for instance, coincident means touching, concentric means they both share the same center point, two circles share the same center point, parallel means the two lines will never cross, tangent means the line is coming from the a line is coming from the curvature of the circle. You have your horizontal. You have horizontal, which means the two parts will be horizontal of one another. We have vertical, perpendicular, equal, midpoint, etc., etc. Anyways, so what's useful for us here is coincident. So we want these 2 points to be touching, so that is a clean, even line. And here we go. So now the line ends right here, and it looks much neater. So now our next two things we need to add are the two circles, one in the top left, one in the top right. So now we have a vague description of what our part should look like. But here's the thing, does this look accurate? No. Now here, that's where things become important. So now that we have a rough sketch, we need to make it dimensionally accurate. So we add our dimensions coming from here. This was a total of 4 inches. And our next dimension is this here, right? This guy right here, which is 2 inches. And again, if you forgot where the dimension tool is, it's right here. Again, you can also press D. So you just take the dimension tool. You click on the line you want to dimension. Like, for instance, let's see, which thing do we want to dimension next? We could dimension right here. So you collect your 2 points, click it. Next thing we want to be 1 inch, so you type in 1 inch, and you press enter. Because you have to select from what 2 points are you dimensioning, 1 and 2. So then you go 1 inch, and there you go. And while these numbers might look different from what you have, it's because these are in centimeters, because my default is in centimeters. However, you can just input whatever input you want. So now for dimensioning the radiuses and diameters of these circles and arcs, it's as simple as just clicking the outside of the arc, which will then be 1.5 inches. One thing you'll notice here is see how it has the R before the number. That means you are calculating the radius, while over here when I put in my dimension, which is 1 inch, is how big the circle should be, you'll notice there's a circle with a cross through it. That means you are calculating the diameter. Let me go over here. This should be 0.5 inches. Simple as that. And our next dimension, actually something to note is that you'll notice as I'm defining things, things will go from blue to black. So for instance here, this circle is blue. That means it is not defined. What that means is that it isn't constrained, as in I can move it. Whereas here, this black, it is constrained. I cannot move it. And that is why also all these parts are constrained to the origin. That means the corner of this box I made earlier is constrained to the origin. That is important, as that means your part cannot move. It is good practice to always constrain all your parts. So our next dimensions are 1.5 inches. And one last one here, 1.5 inches, or actually 2 inches, I apologize. And over here to the right, we have another circle, which is 1.5. And here is 2 inches. And lastly, we are defining this arc from its center point. So you click on the center point, click on the other edge, and now we add 5 inches. As you can see, the whole sketch is black. So that means you cannot move it. You can try all you want, it's not going to happen. So the next thing we have to do is we need to take this sketch from the 2D plane to the 3D plane. That is done by first exiting your sketch by pressing the check mark here. So now we are in the 3D plane and not in sketch mode. You can see as your tools will change in the top to give you tools for 3-dimensional. So here we are going to use the extrude, which is going to change your part from 2D to 3D linearly. I'll explain what that means later. So we press on the extrude button right here. And now it's asking us for the faces and sketches to extrude. And as you remember, we did a sketch 1. In sketch 1, you can click on it here, or you can click on it right here. So here we go. But here's the thing, it gives you a preview, but you can't see it from the top-down view, so I'd recommend going here to your square, clicking on one of the corners, and now you can see how it should change into 3D. The depth of the part is 0.75 inches. And you'll see a bunch of options here at the top. You won't have to deal with surfaces or intersections for now, but new will mean you're creating a new part that is necessary, as there are no other parts on the screen or in this file, so you're going to have to use new. But for instance, let's say you want to use add. Add is only useful for combining two parts. So let's say I wanted to add an extrusion off the top of this part, then you'd use add because it combines the two, because if you use new, then you'll create two different parts. Next you have remove. That is so you can make cuts using that. So you can make a circle and then you can cut everything above or below it, for instance. But for here we are going to use new. So you click the check mark and now you have a 3D object. So for now you are done, but I would like to go through a couple more parts if possible. I would like to go through, let's see, I would like to go through revolve, sweep, loft, the chamfer and fillet, and maybe we can go for mirror too. So let's see, let's create another part. Do the same thing as before, except this time I want the front plane. You'll see why. So I will hide the right and top planes, and now we are left with our front. So I'm going to create a new sketch. Click on the plane that we want to draw on, which will be front. And for most sketches, you're going to want to define your part by the origin. For the first sketch, it's usually quite useful. So now we are going to create a revolve. So an example of this we can make a polygon using this button here. You do not have to do it, but it would be helpful for you if you followed along. So you click on the button, and now you start from the origin, pull out, click again to there, and then one last time to define how many sides you want. I'm going to choose 6 because 6 is a good number. And let's see. Now we need to try and define this polygon. And as you can see, it's completely undefined because it is blue. So our first step is to stabilize how large each side is, which is easily done with the dimension tool. You click 2 corners here, and let's define it. We can click the line. Let's define it to, let's do 1 inch. Now you see it still isn't fully defined because it can still rotate. One way to solve it is to click on one point and onto the origin, and remember these relations I was talking about earlier. They become very useful as the vertical relation will make these 2 points vertical of one another. Click it, and there you go. Now it is fully defined. As you can see, it is black. Now I need to make, for the revolve function, I need to make an axis for this part to revolve around. It'll become more clear in the future, but for now I'm going to select my line tool, create a line going like this. I'm going to make it a construction line by highlighting it and then pressing Q, or you could press the button over here. And now we have our axis of revolution. You can define it here by choosing the distance from the part, so how far the axis it is from its own axis of revolution. We can have it as 3 inches, not particularly important, and the height of it doesn't matter because it is only defining an axis. So now we leave our sketch. You can select revolve, and we are making a new part, so new, and it is solid. You don't need to deal with surfaces for now, probably won't be covered in this course. You're going to select your face and then your axis of revolution. Now let's look at it from the corner so you can see an overhead view of what this should look like. And as you can see, it is revolving this sketch all the way around its axis of revolution. And you can also have it, you don't have to have it all the way around. You can decide here on this drop down menu, if you do one direction, you can define how far around you want it to be. You can set it to be symmetric, so it goes the same direction on either side. Same thing with 2 directions. You can make it go individually, certain directions on each side. But for now, let's just do full. Let's click the check mark, and now we have this weird hexagonal ring. Now I would like to go over the sweep. We can go back to our first part. I think it is something really important. One of the best features of the sweep is for making threads. This is a little extra, but I believe this is something that's very useful for everybody to learn. So in order to first approach this thread, we are going to need to make a helix. A helix as in almost like the shape of a spring, if you can imagine. So first thing we got to do is we can decide how we want to define it. I'm going to define it by the height and the pitch. So the pitch being the amount of revolutions per amount of height, or aka like, yeah. So now we need to define a circular edge, which we can define as the bottom circle here. And then as you can see kind of the beginning of our helix here, but it only has like 1 turn. We want a much tighter turn, and according to the US standard for nuts and bolts, it can be easily defined by 1/12 of an inch here. and the height can extend over it. It's not a big deal. Click the check mark, and here we have our spiral. As you can imagine, the cut of the threads wants to follow this spiral. So one way we can do this is by then making a face almost like we did with the revolve feature, except now that face is going to follow this whole path. But we have an issue. How do I make a sketch on this curved surface? It won't work. So we need to define a plane. So you're going to go over here, click the plane button, and we need to define this plane. You can define it in many ways, as you can see here, but I think the easiest way to do it is by plane and point. The plane will define essentially its angle and to what other plane it is normal to, and then it needs another point to define it, and a great one is the edge of our helix that we defined here. So we click there. So essentially it is a plane that is normal to this plane, and it is this far away from it according to the point. So now we can click our check mark here, and now we have a plane. And one way we'll make this easier to look at is if we go here to this cube in the corner and you click section view. So we're essentially going to have a section view of this part, and you can do that easily by clicking on our plane 1, and look how beautiful that is. Now we have a cross section cut of our part. While this is only visual, this is not actually cutting our part, but it makes it much easier to look at. Now you can go normal to a plane 1. You could either do this by going here and clicking normal to, or you could click on the cube. You can decide which one you like better. Not particularly important. Now our next step. So we have our plane. Now we need to make a sketch. We can make our sketch on the same plane here. And we are going to make a cutout for these threads. So our cutout will be in the shape of a triangle, because that's the standard for most threads. It's quite simply done. We can make a triangle here. But in order to make a triangle, one of the better steps here is to use this tool, project. This takes things from a 3D space and projects it into a 2D space. So it's essentially showing where this 3D object will cut through our 2D plane. So as you can see here, I can click on this edge of this cylinder, and now I can interact with this line in 2D space. So we create our triangle quite simply here. There we go. Use the line to create our triangle. And I will make another line lastly from this point here to the midpoint. You can tell if it's the midpoint by the fact that it creates a square. You saw that little square. So now, or actually I guess I messed it up. So another way to do it is to click here and click your line, and now click midpoint. So now it is always going to be in the middle of this line here. And now we need to define our triangle. So we are going to have it simple, some 0.8 inches, which this is the 0.08 inches. Sorry, I apologize. Which is 0.08 inches, which is the standard threading for the Americans' standard of screws. We're not going to cover metric right now, but this is a pretty simple way of doing it. So now one thing we can do is use the equal function and select all 3 sides of our triangle. You click one, then the next. You click one, then the next. Now our triangle is equilateral. Our next job is to make the center of this triangle align with this 3D helix. What a strange problem, isn't it? So we need to use the pierce relation. So essentially this helix is piercing our 2D shape. So we click on our helix here, and we click on this point, and now it is coincident with our 2D plane. This is a little strange when you're just learning CAD, but trust me, it is very useful. You click the check mark, and now you click our sweep function that we just learned, and we are going to use remove because we are cutting into our part. So now I decide our spaces that we're sweeping with, and I will select our sketch 2, and now we click sweep path, and now we need to select our path that we are sweeping, and here. So as you can see, this is what the final cut should look like. And now all we have to do is just press the check mark, and as you can see, we have threads. But now we want to see our threads and not the section view, so all we have to do is go back to our square here and press turn off section view right here. And now we still have the helix visible, and I think that's kind of an eyesore, so all we have to do is go down here to the features tree, click on curves, and click on the little eye next to curve 1, which is our helix. And now you can see it is now invisible and is no longer bothering us. And now we have some beautiful threads. So that is one of the best function. That's one of the main examples, uses of the sweep function that I can think of. And let's see what is next. The next function, the next thing that's really useful is the loft. It is one of my favorites and one is the most versatile in this program. Here we can make a new part. You can easily do it by pressing the plus and create part studio. Now I'm going to, again, same standard as always. I'm going to decide I want to use the top plane, so I'm going to hide the other two. And I'm going to go to the top. Hopefully by the time you get to here, you are quite familiar with this process and this isn't anything new. So I'm going to create a new sketch to the top plane, and I'm going to create a rectangle here. We're going to go like this. It can be really defined any way we want. Let's go 4 inches by 4 inches. It can be a little square. And let's extrude this bad boy up, and we can press the check mark here, and now we have a cube. Really easy, right? Now where's the loft feature come into play? So one other interesting feature of the sketch is you can also do it on faces of solids. You don't necessarily have to do it on a plane, as you're essentially defining a plane by choosing the face of a surface. So we can do sketch. Now you need 2 sketches. I'm going to be making a cut into this square. I'll show you how, but first our first sketch. We can create a circle on one side, and onto the other side we can create in a different sketch. That's a key. We can create use whatever shape we want. Let's use a polygon. Why not? Let's make it a 5 solid polygon. And now I want to make a cut that will go from this shape to this shape. So I'm going to click on the loft button, and I'm going to press remove because I'm trying to remove material. And now I click on as our profiles. So first one would be this circle. Our second one would be this pentagon. And now we click on them and we can see the preview of what the part will look like. and now we press the check mark, and as you can see, now we have a hole that goes from the perimeter of a circle to the perimeter of a pentagon. Isn't that quite neat? And I think the last thing I want to cover is the chamfer fit and fillet. This is quite useful right here, your fillet and your chamfer. It can be very simply used by pressing on the fillet key. The fillet is a rounded edge, the chamfer is a hard edge. The fillet, you just click on the edges that you want to round, and then you decide the radius of that rounding. I think 0.5 centimeters is fine. Press check, and now we have rounded edges. Look at that. Our next option is to do the chamfer. The chamfer is our hard edge. It functions exactly the same. Let's do a different face. Let's do right here. We can select these 4 sides, and we can decide we want a distance of 1 centimeter here. Why not? And easy as pie. Look at that. Now we have these nice beveled edges. Very simple. And lastly, last but not least, the mirror function. This is a time saver. So now let's say I'm making 2 halves of a car. I only have to make 1 half, and I can mirror the other side over. But for this here, I'm not going to design a whole car here for you. Sorry about that. But now we need to now we can show you this mirror function right here. Click this button. You can choose either you can mirror parts, features, or faces. The main ones you'll probably be using is parts and features. Feature mirroring is when you feature, like for instance, this loft that we just made. That is considered a feature, whereas a part is this whole shape here. So we're going to be mirroring this part, and I want to add to this part. That means I'm combining another side to it, so it'll make 1 part total. And our plane for mirroring. Alright, first we have to select our entity. I apologize. Let's select our mirror plane. You can choose any face. I will choose this one. And merge with all. Or you can say merge with all, or it's essentially deciding which object you want to merge with, but it's only one option, so it's not particularly important. Click the check mark, and now it has been mirrored. I think those are some key tools that you can use. I think you should be able to make most things with this, but let's see, anything else I need to cover? I think that's about it. If you guys need to find me, feel free. I'll pull up the office hours and stuff again real quick. If you guys have any other questions, if things aren't working for you, you can either go to my office hours on Monday or Wednesday, and if that doesn't work, you can always feel free to contact me over email or text me on my phone, and we'll find the time that works for you. And if still that doesn't work, then always feel free to contact the kind people at the Mix at Horizon. They'll love to help you with either CAD or 3D printing. There's plenty of tools and help that you can find. You just have to reach out. Anyways, thank you.